This is Mr. Smith. In his plant, he is the maintenance manager responsible for making sure that the machines always run smoothly and trouble-free. Mr. Smith has been informed by one of his staff that in one of the machines, the gearbox is vibrating and running hotter than usual. However, he doesn't want to just stop the machine for inspection whilst the plant is in full operation, because such a stop is expensive. In order to be able to react quickly and gain flexibility in such a situation, he had already ordered the OELCHECK oil analysis kits in advance. One kit consists of a sample bottle, a sample information form, which is a questionnaire about the oil sample, and a pre-addressed envelope to return the sample in. Mr. Smith quickly and easily takes an oil sample out of the gearbox in question and puts it into a sample bottle. He then fills in the sample information form, places it in the special envelope along with the oil sample, and sends it to OELCHECK. At OELCHECK, the oil is first analyzed in the laboratory using a wide variety of state-of-the-art analysis equipment. Mr. Smith's sample is tested, among more than 30 other data, for oxidation, to ascertain whether the high temperature in the gearbox has already damaged the oil. Wear metals, which could have been the cause of the vibrations, are also analyzed. A mechanical engineer, not a computer, looks at the analysis results. The analysis data and the information on the sample information sheet provide him with an image of the gearbox. Oil can talk. The expert is familiar with the machine and its gearbox, and, based on the analysis results, he can make a precise diagnosis. In the case of Mr. Smith's system, he determines that the oil and chromium content is higher than expected. The viscosity has slightly increased, and that the infrared spectrum reveals minor oil aging. The expert submits his individual diagnosis with the laboratory report. The next day, Mr. Smith receives the results of his oil analysis by email. The general condition of the oil is still good. However, there are first indications of bearing wear. The oil contains some contaminants that could be removed by filtration. To stop the machine or to change the oil is not required for the time being. Mr. Smith can sleep soundly again. He knows that the gearbox will not fail before the next inspection. It saves him money to perform an oil change only when it is necessary and thereby protects the environment. In addition, because initial bearing damage has been detected, he can prepare for a repair. From now on, Mr. Smith will regularly have his machines inspected by means of an oil analysis. By using trend monitoring whilst the plant is in operation, he can find out more about the condition of the machines, detect contamination, damage, and failures even earlier, and avoid unnecessary oil changes. A lubricant analysis is advisable for all equipment, machines, and systems in which oils or greases are used. For example, industrial machinery, its components like engines, gears, bearings, and hydraulic parts, in wind power units, commercial vehicles, generators, biogas engines, turbines, compressors, steel and rolling mills, power plants, paper and cement factories, airplane engines, passenger cars, and truck engines. Oil can talk. We understand the message. OELCHECK. www.oelcheck.com